Hello everyone, welcome to the TSS. In this class, we will build the model. Friends, in the last class, we already gone through data collection process, data preparation process, and the data analysis process. All those stages has completed. Now we have figured out which columns are the most suitable columns for model building. That thing also we had analyzed by using data analysis by exploring the relationship between them. We had concluded the conclusion that see total bill is the predictor variable and tip is the target variable to predict. So to satisfy our requirement, friends, and we need to start building model. So in model building, it will depend upon the machine learning algorithm. Which algorithm to use will depend upon your requirement is if you want to predict the output means if you want prediction, if you want to predict the continuous data type, then you need to use linear regression. So our business requirement or our problem is to detect the tip for based on the total bill. So tip is which data type? That is money. That is numerical data type. That is continuous, not discrete. Okay. So 10.1 or 10.2, $10.3. It will goes on like that. So it is not categorical or string data type. That's why we should select the linear regression as a model building algorithm uh, for achieving our requirement, friends. We should not select categorical these machine learning algorithms. Okay, so these machine learning algorithms is used to detect the output as yes or no kind of things, classification things. Okay, so like that we need to distinguish between the algorithms with their specified use cases. So we need to select a linear regression here. Okay, so let us jump into the Jupyter notebook. Here let us mark down it. Stage 5 model building. Okay, so which model we are going to use? Linear model, linear regression. Okay, model we are going to use, friends. Okay, so in order to build the model, what we need to do first? We need to train the model. Okay, so what is the definition of model building? If you see, model building means training the appropriate model by feeding the data and then let the model learns from the feeded data, and then model will predict the outcome without explicit programming by the programming. That means first we need to feed the data to the model. So from that data the model will learn, model will train, model will get trained up and it will learn something about that feeded data. And then if you feed the next testing data, it will come up and predict the outcome. Okay, so it is like a child, friends. Okay, so these algorithms, machine learning algorithms, how it is like a child. It don't know anything at first, like our child are. So if you want to train your child, what you will do? You will give training to your child. Hey, a little boy, you need to do this thing like this, that thing like that. So you need to play like this, you need to hit the ball like this. Okay, you need to catch the ball like this. Okay, all those things you need to train the child. Okay, So after the child learns from your training, then the child will play by himself, right? So like that only here also, similarly here also the model doesn't know anything. We need to train that model. Okay, the training part is ours. Then it will learns from the input data. Then it will come up and it will predict. Okay, so let us see. For that we need to train the model. So we need to input the training data. So in our hands we have total bill and a tip, both we are having. So that is, this is total bill is predictor variable, tip is um, target variable. So test data we need to training data we need to figure it out. So we need to split our data set now. So for that we need to import sklearn. Here from here itself the sklearn will come into picture, friends. Very very important library for machine learning. From sklearn dot model selection import train test split. Okay, so train test split is a method. With this method will automatically split the data set into training and testing sets, friends. Okay, so we need to train the model first, then we need to test the model. For that we need two data sets. Our data set is having how many? uh, Here you can see pv dot shape. Here we have 244 records are there for predictor variable. Similarly, here also tv dot shape. If you give like this, here also target variable also we are having 244. So we need to split these 244 records into two. That means we will take some chunk of data for training the model. Then we will use the other part of these records for testing whether this model is predicting properly or not. Say suppose if you, for example, if you take 200 records out of this for training the data, then we will use 44 remaining 44 records for testing the data. Okay, so for that we will use train test split method, friends. So we had imported this one, let us import it. Okay, so here you can give training means we are giving input train. So we will name it as properly. For generally it will give x test, x train, x test, y train, y test, like that. So in order to uh, be more meaningful, we will give it like this also. Training input, okay, x train, x test, okay, that means testing input, okay, and then train output and test output. Okay, so the meanings should be understood very well. Training input means we need to give the predictor variable, friends. Okay, this is the predictor variable based on the total bill. We will give the total bill. This is total bill. All the total bill will make the input. Okay, and then we will give the that corresponding output. So first we will tell like that, telling to the child if the total bill is 16.99, the tip is 1.01, and if the tip total bill is 10.34 and the tip is 1.66. Like that we are teaching the model, okay, that is train input and the train output. And test input and test output is after training the model we will give some remaining, like that if 200 columns are selected for training the data, the test for testing purpose we have to input this 44, okay, 44 records, and then we will only input this 44 records predictor variables. Then the target variable will be predicted by the model itself. Then we will compare that target predicted variable with this target variable, friends, okay. So let us here you may be there may be more chances for confusion. If you do uh, more practice, then it will be understood by you. This train set, test set, okay, all these things, okay. So you need to use train test split of what, the x and y you have to give. That means it will take two variables. Here you can see the help, okay. Train test split arrays or matrices into random train and test subsets, okay. So here you can use like this train test split. uh, so you need to give the uh, target variables and the predictor variables both. So predictor variables is the independent variable, that is PV, and dependent variable is tip, so that is TV, okay, TV. And then random state, random state is equal to 1 over 1, okay. It will shuffle this thing, it will don't follow the sequence, it will shuffle, friends. So if you run it, it will execute it. Let us see what train input variable consists of, okay. You can see now the total bill was segregated, okay. Out of the 244 columns, how many I mean 244 records, how many records was assigned to training input by this function, we will see. Here you can see it was shuffled, it was not the sequence, okay. 183 rows was assigned out of 244 rows. Training input was assigned to 183, okay, 183 rows, friends, okay. And then the test input is also the we can see, okay. Test input, okay. Test input is also the total bill, which is this set is used to test the model after the training, okay. 61 rows, it was taken 61 rows for testing, 183 rows for training, okay, clear. And then we need to uh, display train output. This is the output, friends, the train output, that means the tip corresponding to the training input, that is training input is where, here, training input. For this, how much is the tip value, the 15 will corresponding to the 15 here, okay, right. Likewise test output, sorry, test output, okay. This is the tip for the test input of 151 here, I think, yeah. For test input, that is 151th row, if the total bill is 13.13, So the tip should be 2. Okay. So these sets are automatically splitted by this train test split method. The name itself it is telling. Okay. Training set test set it was splitting. Okay, we had named it appropriate variable names, training input and the training output. So we need training train the model both the input output at the training stage. We will give both training input and the output. So and in the testing stage we will only give the test input, then the model will come up and predict some value, and the predicted value is compared with the test output. So that is the way. So let us now we need to import the model. So from sklearn, from sklearn uh, sklearn dot linear model import linear regression. Okay, so this is the linear regression model which is readily available in the sklearn library, friends. We need to import that one. Okay, for model building. So it was imported. Now we need to make a model. Say our model is linear model. No, say linear regression. Okay, so linear regression, that is simple linear regression. Say SLR is equal to, we need to make the instance. Okay, a object out of this linear regression. So we had run that one. Then we need to call the fit method. So here the magic happens. Fit method means training, TRI, training the model with uh, the PV and TV. That means a predictor variable and a target variable, that is train input. Target variable means train output. Okay, so at first we will give both the input and the associated output. So by giving these two, we will train this model. This is the fit method. Fit method is used to train the model. So we need to give train input and their associated output also. So that means predictor variable and target variable. Okay, so we had run that one. So linear regression model, as the model was trained. So this is very simple here, but if you do it with a pen and paper with all those mathematics, it will, for all the number of 244 rows, it will take 5 to 6 hours, friends. Okay, so that is the power of Python and sklearn library. So all those mathematics was done. So how this linear regression will work behind the screens, all those points I'm not discussing. So it takes lot of mathematics. Okay, so but I will simply tell the principles behind the linear regression after explaining these things, how it is working. Let me first code the things, then I will come back and explain. Let me show this magic to you first, then how it is doing I will tell. So fit means training the model by giving the input and their corresponding output. That means predicted variable input and the target variable, we are both we will give, so that the linear regression model learns from this. Okay, so training and learning will happen in this 62 cell itself by using fit method. Then we will, so the model has ready. Okay, we had ready, the model became ready to predict the things because it already trained up, and now it is ready to predict the things. Okay, so SLR dot predict. So predict is the method to predict the things because already the model has learned from these two things. Now we have to test the model. So in order to test the model, we have testing the model with what? Test data. So test data. So what test data we have? Test input. Okay, test input data. So test input data is what? Go up and see. Test input. Here is the test input. So we are giving now the model the 151 row. Okay, $13.13, and the model will has to predict the test output. What is test output here? Okay, so like $2. Okay, $2 it should predict, and like that we will give 34th row the total bill. Then it will come up and it has to predict 3.2. If it doesn't predict 3.27, and if it suppose it predicts 2.8 something, then there is a difference. Okay, how near the prediction is, that much efficient the model is. Okay, so our predictions has to be, our model predictions has to be very close to the actual. Okay, so test output is the actual. Okay, so test input is the uh, data we are going to give to the learned model to predict. Okay, so let us give test input, and we will store it in a predictions variable. Okay, so by giving this test input data set to this learned model, it will predict. Okay, let us run it. Okay, predictions come up. Okay, predictions. So let us see how it was predicted. Okay, it has predicted some values. Let us see side by side in the form of data frame so that it will be better. So we have test op. Okay, dot head. Okay, like this. So let us make predictions is also a data set, friends, so that in side by side we can, if you can see, then we will come to know predictions. Let's make it as a data frame, that is pd dot data frame of predictions columns is equal to prediction. So we have named it a column as predictions. Okay, and we had say let us call some predictions was passed. PD dot data frame of, okay, predictions we had data. What's happening here? Predictions. Okay, we had an array. We need to convert it into a data frame. PD dot data frame of, let us see predictions. Okay, it was come up. Then we need to, okay, this I forget, predictions. Okay, so now we did that, say some, okay, so we had predictions, let us name it as df, and we have train test op. Okay, let us join these two, df, okay, test op dot join what df. Here this is the actual. Okay friends, 34, okay, otherwise, okay, otherwise we can do like this, it is giving none because it predictions. Okay, okay, let us forget about it. Let us where it gone, ah, here, okay, so list of we can give like this, list of predictions and test op, okay, test op, then columns actuals, okay, actual, okay, forget about it. So here, from here, okay, so from this there is no doubt, then predictions, okay, so I am trying to make a df here, so and some bit is missing, okay, no problem. So these are the predictions friends, it is a predictions, and the test for 150 first row, what it is having, okay, the tip is having uh, 2, but the prediction is 2.30, okay. So for the second 3.2 it has to predict, but it has predicted 2.81, okay. So and in the next the tip is 4, and but it has predicted 2.43, so wide variation is there, okay. And 2.98 the fourth, but it is predicted 3.5, very close. So like that it has predicted friends, okay. Here you can verify it, it was all predicted by first in this stage, it learned from the training data, and then it will predict the inputted test input, so it predicts the uh, tip based on the test input of the total bill, okay. So now the predictions is compared to the actual test output. So so this is the test output sample and the corresponding predictions here. Okay. So this is the comparison, friends. So it will go like this. Then we will see how accurate our model is. So how accurate our model is and all those things we will see in the next class, friends. That will comes under model evaluation. So how it is going to predict, let us discuss. So linear regression means, so there is, it will depends upon the y is equal to mx plus c. This is the formula. Okay, friends, this is the key formula. And then uh, so y is dependent variable, friends. Okay, and x is independent variable, friends. And then what m is, what m is called slope, and c is called y intercept. Okay, it is called intercept. See, if you know the x value, so x value is the independent value, so the y will be determined by all these three parameters, friends. Okay, listen carefully, the y, so y is the dependent variable. Why? Because the y value depends upon this equation, that is xmc. Let us see what is xmc. X is the independent variable, that is which we are going to input to the model. In our case it is total bill, right? Okay, this is the independent variable, and based on this total bill we need to predict the y dependent variable, that is tip. Okay, so by with the independent variable total bill, the tip should be predicted. So these two values is not enough, we need m and c. Okay, what is this m and what is this c? M is the slope and c is the intercept. Okay, we need to find this m and c value. Okay, this m and c value the model will learn, friends. Okay, for m we have a formula, for c we have a formula. Okay, so if you if you run it, this is the mathematical theory behind this model, friends. So let us slr dot say coefficients. Let me uh, give that coefficient. That coefficient is the slope. The slope is also called as coefficient. In this case it is m. Okay, so m value is 0.10, and the same way intercept. Okay, let me give the intercept. So intercept is 0.86. This is the value of c. So the model will learn m and c. Okay, the rest we are having x. So we are having the x variable with us as a total bill. So after train the model by training set, it will uh, learn the m value and the c value. So with the formulas, m is equal to one formula is there, c is equal to one formula is there. So with these formulas, it will learn the m value and c value. Then the y value it will suspect, friends. It will predict. So this is the theory behind this linear regression, friends. And in the next class we will discuss um, model evaluation, how the uh, how accurate the model is, because we are having the difference, the tip for this particular 150 first row, the tip should be 2, but the prediction is 2.3. That means zero point 0.3 value variation will be there. So like that it will compare, we have to compare all the tip to actual to the predictions, then we will come up with the accuracy. That part we will see in the next class. So till then, bye bye. Your Svira signing off. Thank you for listening.